Bismillahirrahmanirrahim. Iyaka na'budu wa iyaka nasta'in. Assalamu alaikum and welcome you all to the yet another interesting topic about preparations of salt. This belongs to chapter number 10, acid, bases and salts. So let's move towards the preparation of salts. You know that whenever we are talking about the solubility, we come across to the point that we have to dissolve that salt in water, and we have to decide at that point that whether that salt is soluble in water or insoluble in water. The method of solubilities and the preparation of salts are based on their solubilities in water, and the most general methods are basically 5, in which 4 methods are related to the preparation of soluble salts, but only one method is there which is linked with the preparation of insoluble salts, and that is most commonly called as precipitation method. So before that, the point to be noted, and that is the well marked points, that all the nitrates, which are basically the acid radicals having NO3 minus, and all ammonium ions, that's a basic radical, sodium ion, again the basic radical, and potassium salts are always soluble in water. Whenever you see a presence of ammonium, sodium and potassium, they are always soluble in water, and one negative anion radical is there, which is nitrate. So these salts are always soluble in water, and mostly chlorides and sulphates are soluble, but the majority of carbonates are insoluble. To make it more clear, we have a flow sheet to categorize the salt into soluble and insoluble. So let's have a picture that all salts of sodium, potassium, ammonium and nitrates, they are soluble. Mostly chlorides, but we are having the exception that PbCl2, which is lead chloride, silver chloride, mercurous chloride, they are insoluble in water. Mostly sulfates are soluble except barium sulfate, lead sulfate and calcium sulfate, and the exceptional cases are that all the carbonates CO3 minus 2 are insoluble, but except when you are having sodium carbonate, potassium carbonate or ammonium carbonate, they are soluble in water. Now let's see that which particular methods we have to apply. First thing, or the first question which comes in our mind is the salt to be prepared soluble in water? Obviously, at that point, we come across to either the answer yes or no. Yes or no answer is further having their own specification. For example, that if I said no, it means that we are going to prepare an insoluble salt by the method of precipitation. And in this method of precipitation, what we do is that we have to take the combination of 2 soluble salts, and they react with one another to give you one insoluble salt and another soluble salt. But when the answer is yes, that is seen on your left hand side, when the answer is yes, then you recall the following reactions, that either acid react with metal oxide, base or the carbonates. But again, at this point you come across to a question that whether that starting material is soluble in water or not. Because this question arises is further lead and make it variable for its recovery, as well as it suggests different methods for preparation. So first, when I said that starting material is not soluble in water, that simply we go for acid plus metal, because as you know that metals are solid. Second situation is acid plus excess insoluble bases, like bases of iron hydroxide, copper hydroxide, aluminium hydroxide and so on. And the third option is acid plus insoluble carbonates, those carbonates which are the acceptations of rather than sodium, potassium and ammonium. As you know that all carbonates are insoluble as compared, as you can consider the carbonates of for example calcium carbonate. It falls in this category, that acid plus excess insoluble carbonate. When you are having this situation, then simply you have to go for the method number 1. Now we are having a second option. When you go for the answer yes, that the starting materials are soluble in water, then you simply go for titration method. In this you are having acid plus alkali. Alkalis are either NaOH, KOH, ammonium hydroxide, that all bases which are soluble in water, and most likely you are having the bases of sodium, potassium and ammonium. Secondly, whenever you see that acid plus soluble carbonate, you always carbonates like sodium carbonate, potassium carbonate, ammonium carbonate, you always go for titration method. Now over here, the point to be noted is their recoveries are different according to the different methods. When you go for the method number 1, the additional step is that you have to filter it. Why there is a need to filter it? Because you are having that starting material which might be insoluble in water, and then for that you have to filter it and you have to collect the filtrate, and then you have to concentrate, crystallize and then filter. But for the separation or the recovery in case of method number 3, precipitation, you simply go for filtration process. Okay, fine. Over here you are having the whole scenario and whole picture. Firstly, we start with the salt solution, and this is the case where you are having either the method number 1 or method number 2. When you go for the method number 1, the additional step is the filtration to check it out that either any unreacted substance is there or not. Then you have to collect the salt solution, and this further 3 steps: concentrate. Concentrate means you have to heat it and you want to evaporate to saturated point. Then you have to crystallize it, you have to cool it so that the crystals will appear. And then final step is you have to filter it so that you can collect the crystals on the filter paper. And then simply you have to dry it and collect the filter papers, precipitates. But for the insoluble salt, the only one particular method is the filtration. You go for the filtration, and the insoluble materials salt will be on the top of the filter paper and the soluble salt will be in the solution. So let's practice it with some examples. For example, the question is which method is used for the precipitation of each of the following salt, and the first salt which comes in our mind is NaCl. Now I have selected 3 salts for you so that we can come across and go for the practice. Second salt is copper sulphate and third salt is copper carbonate. Now first, in order to proceed, what you do is that you have to select that whether that salt is soluble or insoluble. As far as the sodium chloride is concerned, the salt is completely soluble in water. Why? Because salts of sodium is always soluble in water. So it means the precipitation methods will be cancelled out. Secondly, that we have to select among method number 1 or method number 2. When you go for the method number 1, the starting material is not insoluble in water. That means we omit method number 1, and then we simply go for the titration method, which is a neutralization reaction. And in that particular case, what you select is you simply select acid react with base to give you salt in water. You simply select Na in NaCl. Na is the basic radical which comes from NaOH, and HCl gives you acidic radical which is Cl negative. So both NaOH and HCl react together to give you NaCl and water. And what is that titration method is? Let's have a look on it. Titration method is actually the acid-base titration or the volumetric analysis. And this is a burette in front of you, and it's having 50 centimeter volume. It can carry 50 centimeter cube of volume, and you have to fill it till 0 mark with acid. As you know that HCl is colorless, NaOH is again colorless, and in order to react them together, you will get NaCl which is again colorless and water which is again colorless. So you have to put an indicator so that it can show a different color in acid and in base, and when the reaction takes place, it gives you a different endpoint. So what you do is that you have to fill this burette with HCl, and with the help of this pipette you take 10 ml of NaOH, putting 2 drops of phenolphthalein in it, and then ultimately with the change in color you can come to know that endpoint will reach and NaCl and water is formed. Let's have a look on this video. In this video, NaOH 10 ml is measured and added into a conical flask, which is also called as a titration flask. After putting NaOH, what you do is that you will see that NaOH is colorless. Okay, fine. Then you have to add indicator in it. Phenolphthalein always give you pink color in NaOH and remains colorless in HCl because phenolphthalein indicator itself is having a weak acidic character. This is a funnel which is placed over it, and this is used to increase the surface area while adding the HCl in burette. Finally and slowly you have to fill the whole burette till 0 mark with HCl. After filling it completely, you have to remove the funnel. Then you have to add indicator. Let's see the color, which is pink color in basic medium. Then you are going to titrate it. You have to allow and add HCl drop by drop till the light pink color will appear, which is considered as an endpoint. You are not going to take that color almost colorless, because that colorless is not the end point. You have to turn it into light pink, which is the end point. And from this you have to note down the volume, that how much volume of acid will be consumed, and then you go for the calculations. Now let's proceed towards the reaction. HCl react with NaOH to give you NaCl and water, and ultimately you will get the colorless NaCl and water, and from that you can go for its recovery as well. As you know that the starting material both are in aqueous state and both are soluble in water, so you get a soluble salt, so there is no need to go for a starting filtration process. You simply go for concentrate. You have to heat it, evaporate it till saturation point, then you have to crystallize it, cool it, and then finally you have to filter it to get the precipitates and wash it. Now let's proceed towards the preparation of second unknown salt, which is copper sulphate. First most important thing which keeps in your mind is that copper sulphate is whether soluble or insoluble. Actually, copper sulphate is soluble in water. So it means the third method, precipitation method, will be cancelled out. Secondly, we have method number 1 and method number 2. As you know, the titration method is specifically for alkalines and soluble carbonates. So we also omit method number 2 and we come across to the method number 1. Either we have to react it with the acid, with metals or metal oxide, or with insoluble bases. So in this particular case with copper is least reactive, so we prefer to react acid with copper oxide. So sulfuric acid is reacted with copper oxide and it will give you copper sulphate plus water. Then as you know that copper oxide is in solid state, so for its recovery you have to go for filtration process first, so that if any unreacted copper is there, you have to omit it, and later on you have to collect the filtrate, and then you have to concentrate, crystallize and filter it. So I think that this is very helpful for you guys and make it understandable that we can't directly react copper with sulfuric acid. We have to select its copper oxide and treat it with sulfuric acid. Now last practice is our precipitation methods, that how we gonna prepare our insoluble salts. Two things keep in your mind, that we have to select two soluble salts, and when these two soluble salts exchange ionic radicals, they produce two new salts. One is soluble, another is insoluble, and it is very easy to recover it. Simply you have to filter it, and then you get a insoluble salt on the top of the filter paper, and then finally you are having that soluble salt in the solution. So how you gonna prepare copper carbonate? You know that carbonates are coming over here. When you select a two soluble salt, one thing should always keep in your mind, that whether you go for sodium salts potassium salt or ammonium salt, and another salt would be any heavy metals. But when you want to find the heavy metal soluble in water, then you have to take the nitrates form of it. So in case of copper carbonate, you select carbonates are coming from sodium carbonate and copper is coming from the soluble salt of copper sulphate. So ion double displacement reaction will take place and copper exchange ion with sodium, and you will get copper carbonate, which is solid, and sodium sulphate, which is soluble in water. And then how you will go for its recovery, that you have to filter it and you have to collect the precipitates, and you have to wash the precipitate with a small amount of the distilled water and allow the precipitates to dry, and thus through this process you can collect the copper carbonate solution. I hope all the queries and all the related problems related to preparation of salts make easy for you. Inshallah, we come across with a new topic. Allah Hafiz from my side.